relationships. We're going to talk about opposite angles, which are vertical angles. We're going to talk about supplementary angles, complementary angles, corresponding angles, and how can we use all of these angles to find measurements without using a protractor. Well, the first one we're going to talk about is a complementary angle. Complementary angles are two angles that measure 90 degrees. If I can find the measurement of one of the angles, I can find the measurement of the other angle. So if I say that this one angle here is 23 degrees, how much would the other one be? Well, 90 minus 23 gives me how much? Well, that's 67 degrees. So this part would be 67 degrees. Both angles added together mean 90 degrees. They're complementary. One trick that I use is if you make the C for the beginning part of complementary and you join those end lines together, it makes a 9. It kind of reminds me, oh, 90 degrees. Here are some practices for those. If you have one angle that's 62, how do you find the others? Well, 90 minus 62 gives me how much? Well, if you subtract, you find out that it's 28 degrees. Both angles together have to equal 90. Here's another one, 90 minus 63 degrees. Well, that gives me 27. That means this angle must be 27 degrees. Here are some more you can practice. What if one is 16 degrees, like here? If I have 90 minus 16, what do I get? Well, do the subtraction. You would get 74 degrees. Making sure, 74, sorry. Making sure both add up to 90. Another type of angle that we have is a supplementary angle. A supplementary angle are when two angles added together make 180 degrees. They form a straight line. That's 180 degrees. So if I know what one angle is, let's say this angle is about 27 degrees, I can find the other one. 180 minus 27 gives me what? 153. This angle is 153 degrees. My trick for remembering supplementary is kind of the same. If you make an S and you join the two endpoints together, it makes an 8. Kind of giving you that memory, it's 180 degrees. Here's some examples of those. If one angle is 129 degrees, how much is the other? Well, 180 minus 129 is how much? 51. So this angle has to be 51 degrees. If one angle is 135 degrees, how much is the other? Again, two supplementary angles equal 180 degrees minus 135. How much do we get? 55 degrees. Oh, I'm sorry, 45 degrees. Got to work on my subtraction a little bit there. 45 degrees. All right, there's a couple more for you to try. Go ahead and give them a try and see how you do. Now we're going to look at two lines that intersect. Well, when we look at this line, first of all, we have to know how to read it. It's telling us the drawing above, angle 1 is 135 degrees. The way that that is written is this way. It means the measurement of angle 1 equals 135 degrees. The M stands for measurement, and that symbol you see there stands for angles. That is how you will see it mostly written. So now, if I know that angle 1 is 135 degrees, how do I find the rest of the angles? Well, I can use what I know about supplementary angles to help me. So, if angle 1 is 135 degrees, how much would angle 4 be? Well, they form a line. Here's my line, so they're supplementary. So angle 4 would be 180 minus 135. How much would that give me? Go ahead and do the subtraction. Borrow when you need to. This would find out that this is 45 degrees. Now find out what angle 3 is going to be. Well, again, if angle 4 is 45 and angle 3 and angle 4 form this line here, we can do the same thing. 180 minus 45 to find out that angle 3 is 135 degrees. And then find the last one, which is angle 2. Again, using what we know about a line, because 2 and 3 form a line, so I can do my subtraction again. 185 minus 135 gives me 45 degrees. Now I know the measurement of all four angles that I have here for these for these intersection lines. So which ones measured the same though? Well, you can see that angle 1 was equal to angle 3, and angle 2 was equal to angle 4. Those angles, the measurements equaled each other. So what pattern was that? The pattern would be that opposite angles equal each other. Right now, there is a name for those opposite angles. Those opposite angles are called vertical angles. So when you look at vertical angles, they are right across from each other. Those angles have the same measurements. So if I looked at this diagram, I could say that angle W equals angle Y, and angle X equals angle Z. They have the same measurements, and they both make those lines, so you would say that the total degree of all four angles is 360 degrees. You'll get that circle effects with those two half circle lines. So how do I find the measurements of these ones? Well, if I know that one of them is 47, and I know that vertical lines are equal, I know that angle 4 is 47 degrees. And then I also know that angle 4 and angle 1 make that straight line, so I can find angle 1 by taking 180 and subtracting 47. And then I would find out that angle 1 is 133 degrees. So if angle 1 is 133 degrees, what's angle 3? They're vertical, so it's also 133 degrees. Now look at the next one. One angle is 105. The vertical angle to it must also be 105 degrees. So that means angle 1 is 105 degrees. Angle 1 and angle 4 make a line. So take your 180 and subtract 105 to find out that angle 4 is 75 degrees. And if angle 4 is 75 degrees, how much is angle 2? It's also 75 degrees because they're vertical angles. Now let's take a look at this diagram. It looks hard, but it's not. Let's break it apart into sections. So I'm going to cover up part of it for you, and we're going to start with the top section. Again, that looks just like what we did. I have a 61-degree angle, so the vertical angle must be the same, and that's B. So B must be 61 degrees. If B is 61 degrees, I can find A because they form that line. 180 minus 61 gives me how much? Well, I'm going to find out that it's 119 degrees. And again, A and C are vertical, so if A is 119 degrees, C must be 119 degrees. Let's go down towards the bottom. Again, we have that four sections again. 85, whoops, excuse me. Let's get that back over here. 85 is vertical to what angle? It is F, so F must be 85 degrees. If F is 85 degrees, I can use F and E, make a line. What does that give me? Well, 180 minus 85 gives me how much? 95. So that means E is 95 degrees. And E and D are vertical angles, so that means D is 95 degrees. Now let's look at the rest of it. Well, the easiest one to see here is J. J is a straight line. We already know that straight lines are 180 degrees. Now I have to find G and H. Well, together they have to equal 180, but how do they find them? I'm going to take out my highlighter here, and I'm going to highlight this area. What am I making? I am highlighting a triangle. Triangles equal, the areas of all three angles in there equal 180 degrees. So if I have 61 and I have 95, I can find out what G is by adding them together. So if I add them, I get 156, and then taking that and subtracting it from 180, because triangles angles equal 180 degrees, to find out that G is 24 degrees. And G and H make a line, so if I take 180 and subtract that 24, I'm going to find out that angle H is 156 degrees. It's easier than it looks when we break it apart. Okay, now let's look at these. They look more complicated than they are. They're two parallel lines split by another line. That line that's splitting them, this is called a transversal. This line is called your transversal. Just a fancy word to say I cut two parallel lines someplace. Now I have to determine what the measurements are. Well, line 1 there is a straight line. Straight line makes 180 degrees. If one side of it is 95, how much is the other? Well, 180 minus 95 tells me that this angle is 80 degrees. So angle 1 is 80 degrees. Now, how do I figure out what the rest of them are? Well, angle 2, 3, and 4 are not that complicated. Watch what I'm going to do. I'm going to get out my highlighter and I'm going to highlight this 95 degrees. It's at the top of a parallel line to the left of the transversal. Now, if I move that parallel line down, that little highlighted part that I made, look how it fits exactly in to angle 2. Those are corresponding angles. That means that 95 and angle 2 are the exact same amount. So I can go ahead and say that angle 2 equals 95 degrees. Now, if I know what angle 2 is, it's pretty easy to find angle 3 because they make that line. It's corresponding to angle 1 if I would move it down. It's at the top of a parallel line right of the transversal. So that one is also 80 degrees. And then 3 and 4 are vertical angles. That means that they are the same. So that one is also 80 degrees. Now look at the next one. It is also a transversal. All we did is turn it on its side. We can use the same tricks that we know. Well, 60 is vertical to angle 1. So that means angle 1 must also be 60 degrees. And then I can highlight it to try to see where it would go up the transversal and be the same. Well, if I move it up, you're going to see that it is exactly corresponding to angle 3. That means that angle 3 is also 60 degrees. Now I have to find 2 and 4. Well, angle 2 and angle 3 make a line, so I can make 180 minus the 60 to find out that angle 2 is 120. And angle 2 is vertical to angle 4, and we know vertical angles are equal, so angle 4 is also 120 degrees. Now the last one has the two parallel lines, and the transversal cuts exactly across at a 90-degree angle. That is perpendicular lines. And we already learned that when lines are perpendicular, the angles within those perpendicular lines are all going to be 90 degrees. You can now do page 7 of your homework. We're going to go ahead and keep practicing in these class. Please practice in your yellow book. There's plenty of practice problems, and ask questions if you need to.